Good afternoon, everyone. Thank you for joining our webinar today, uh, which we have titled as Transform Your Design Workflow with 3D Experience CATIA. Today's webinar will be delivered by Mr. Sri Kumar Maganti. Just a brief profile about the speaker. He has more than 23 years of experience in engineering applications, serving in transportation and mobility, aerospace and defense, industrial equipment, marine and offshore, and energy process and utility segments. He has worked on-site with clients like Ashok Leyland, Daimler, ADA, Tech Mahindra, and Cyient. He is a specialist in technology sales, corporate trainings, and technical support. He is a certified global professional on PLM and digital experience platform. He is also a topper in automobile engineering from Gulbarga University and has masters in CAD/CAM CAE and mold design from CPET. If the audience has any questions during the course of the webinar or any queries regarding the topic, they can always put their questions in the question box where our speaker will attend to it after the delivery of the session. Over to you, Shikumar sir.
Thank you, Abhay. You're able to see my screen. Thank you, Abhay, for the introduction. Today's webinar is on transforming your design workflows with 3D Experience CATIA. I'm Sri Kumar. I have been with EDS for the last 20 plus years. I look into technical aspect of 3D Experience brand as a whole. And before getting into this webinar, I would like to give a small introduction about our company. So EDS Technologies has started way back in 1995 in India, and then we had our own product called Deneb Robotics. So in order to sell our own product Deneb Robotics, we have started this organization, and as we moved on, this Deneb Robotics was acquired by Dassault Systèmes, and we became natural partners with Dassault Systèmes. So we started providing. So we are headquartered in Bangalore. Again, we have our presence in Chennai, Coimbatore, Mumbai, Ahmedabad, Pune, and also Noida and Gurugram, and also Calcutta. So we have a strong technical support and sales organization, and again working in multiple regions. So we provide technologies like 3D printing, virtual twins, digital manufacturing, and also realistic simulations. We also provide solutions for power electronics and embedded systems. So we are into multiple, I can say portfolios of the product development cutting across multiple industry segments. So we cater to transportation, mobility, aerospace and defense, industrial equipment, high-tech and electronics, consumer goods, marine and offshore, and also to all the engineering service providers and global accounts. So this is a small introduction on EDS Technologies. So I'll move on with today's webinar. And we are today catering to more than 2,000 active customers across India. We are close to 250 plus associates, again spread across 10 locations. So today's agenda is on 3D Experience platform, CATIA, basically. So in order to have the design excellence and design workflows efficiently on 3D Experience platform, today we are looking into these topics. So I start with introduction to 3D Experience platform, followed by concept engineering, then generative design for design optimization, followed by model-based definition as a reliable source of truth, and then we look into model-based systems engineering MBSC, and digital experience platform, 3D Experience platform as a unified environment for all kinds of applications, and then we look into innovative design approach using artificial intelligence, virtual reality, and cloud computing capabilities. So 3D Experience platform has been growing faster across the globe for many years now. It has started with V6 technology in 2009, and today there are more than 3,000 OEMs who use Dassault Systèmes 3D Experience platform for their innovative projects. So to start with introduction on 3DEXPERIENCE platform, basically this is a business experience platform, which is again digital in nature, and basically to provide the holistic experience to the consumers. So the delightful customers are the main objective of this platform approach. When we have different platforms like payment platform, say we have multiple UPIs like Google Pay, Phone Pay, or many other applications available on internet today. So we make use of those payment platforms to deliver our digital transaction as a digital consumer. Similarly, we have a platform meant for I can say operating systems. There are platforms meant for travel and tourism, right? So there are several platforms which are developed for different businesses. But is there a platform which will support our needs? Say like with respect to transportation, mobility, or aerospace and defense, or consumer goods. Do we have a platform which will deliver all the applications on a single platform and synchronize all the softwares under one single umbrella? So that's where Dassault Systems has started this platform approach, and they have been progressing very well on this digital experience platform. And if you see the compass which is on the left side, it comprises of 4 quadrants. One is on the 3D modeling applications CATIA. So when I say 3D modeling applications, it is not restricted to CATIA or SolidWorks, but also it can cater to NX, AutoCAD, Creo, or any other popular softwares in the market. Similarly, we have North Quadrant, we have social collaboration applications like Anovia, which is a major application for social collaboration and PLM. And then we have virtual plus real time, that is Delmia and Simulia brands on virtual plus real time experience solutions. And we also have an important quadrant East, which is on information intelligence. So today we are talking about data science, data analytics, and intelligence. So that's precisely where we can definitely work on with in the same platform approach. So this platform can be an important user interface for 3D design, analysis, simulation, and also the data intelligence, which is all inclusive, and also it is accessible to any persons across the organization. That is all the stakeholders in the organization who can access from anywhere, anytime on any device. So that's a digital approach. With the latest information and data, you can access this in a secure fashion, but whether it is on-premise or on cloud. So this is how this platform has been developed with all the latest information on all these brands. So these brands cater to again the digital way. All you have seen till date today as a CATIA V5 existing user is that you have been using the electronic softwares. CATIA V5 is electronic in nature, whereas AutoCAD or SolidWorks or all these applications, including NX, Creo, these are all electronic software applications in nature. But when it comes to 3DEXPERIENCE CATIA, this is a digital CATIA, digital software, and it caters to the anywhere, anytime on any device in a digital way with the latest information or data. So that's the power of digital software which is coming in place. So as we move from CATIA V5 to 3DEXPERIENCE platform, so big transformation happens in terms of the digital experience, I would say. So it has got a complete range of applications. Again, whatever that is 100% is carried from CATIA V5. On top of that, there are several applications and roles which have come up on 3DEXPERIENCE CATIA, which will also provide the gateway to the outside world, outside the organization. So I will just look into highlight some of those what you call concept engineering first. So what kind of features have come in and what way the technology has evolved on 3DEXPERIENCE CATIA, I'm going to highlight on that. So some of those important ones, I mean, CATIA is a ocean. It has more than 200 roles, connecting with different modules. But I'll try to cover, the important aspects of 3DEXPERIENCE CATIA. Which is basically much more developed and more evolved from time to time. So here I'm taking the example of concept engineering. So when I look into the concept engineering, now I take an example here with respect to industrial equipment. Typically, there are rollovers that happens for the excavators. So in this example, like rollover productive structures needs to be built up. So when we look into the model, for this excavator model, so we look into the basic design aspect, which should not fail during the rollover, and it should be able to withstand the angle, basically angle at which it is trying to fall. So here we look into multiple parameters in terms of concept engineering. So we need to look at three different variables, basically. These three different variables will control our design and say whether it is really feasible or not. So we look at the design variability from component variability perspective, material variability perspective, and also from parameter variability. So when I look at the component variability, now this kind of applications are inbuilt in, the knowledge where is inbuilt into this. I can make the alternative designs very quickly using this concept engineering. Here I'm able to check the component variability, different kinds of, the platform for this excavator, which can stop the rollover. Similarly, I can change the material variability. I can also change, what do you call, the parametric variability. So I can look at the different shapes, right? I'm just coming to this. Yeah, I can look into the simulation aspect. Now, different shapes I can see here, which basically based on the parametric variability, I'm able to change the shapes at a mouse click of a button, mouse click, and then I'm able to see the different shape of a complete excavator module here. Similarly, I can also test it for structural conditions. Basically, the structural integrity also can be tested with the help of simulations within the same application. So here we are able to seamlessly move from one workbench to another workbench, say from design to simulation or manufacturing. We are able to seamlessly move in the same unified environment. So in this case, now we are checking the simulation aspect, which is meeting the requirements of the ISO standard, which is mentioned. So now we can look at the design exploration. We can run through design of experiments and find out what kind of material is needed, what kind of parametric model is needed. We can actually look into all aspects and run through this design of experiments to find out the most optimized design of this excavator. So the software will run through this algorithm and will try to find out the best of optimized shape for this excavator, and it will help you to identify the best possible optimized design through this design of experiments. So now we are running through design, simulation, and optimization of the design in such a way that this excavator doesn't fail or roll over in the real time and conditions. So this is how the concept has been built into this CATIA 3D experience. I would say 3D experience CATIA, and this is how it is serving the purpose. So we are able to define different metrics. We are able to define the metrics, whether it is component metrics or parameter metrics or material metrics. I'm able to define them, and I'm able to run through the basic simulations and also run through the structural integrity and find out that through design of experiment, find out the optimized design in this fashion. So this is something which is really available on 3D Experience CATIA. So there are also again some more important features I would like to touch upon. When it comes to core modeling productivity, definitely CATIA has improved leaps and bounds. So you might have seen the sketch tracer module earlier in the past, but it is much more than this. You are able to bring out all those 2D images onto three different planes, and you are able to build the complete model accurately, using this approach. So here we have CATIA natural sketch. You just have to pick up the right image and cut it and paste it, and then having three planes in place, you are able to build the datum planes, and you are able to create the simple revolute, which is a projection of the image, basically, right? So the image can be simply drawn with the help of the images. The sketch can be drawn with the help of images which are highlighted on a different plane. So now we can do the revolute and come out with the basic shape, and then referring to all the three views, we can go into the multiple feature operations, whether it is pocket or extrapolate, or it could be any cuts. We can prepare all that. Now we are referring to these 3D views. which we have taken from the 2D images. Basically it could be PDF file or image file or JPEG file, and you bring that into CATIA and you are able to develop the 3D model seamlessly using this natural sketch approach. Again, this natural sketch is very much highly evolved compared to what is there in CATIA V5. Similarly, we can also check and repair some of those surfaces. So here we can set the restraints and check for different gaps, check for small faces, and we can check for multiple conditions. Once we run through the checking tool, we are able to find out which are those defective surfaces. We are able to repair them very effectively using the basic role of mechanical and shape designer. So here again, this is much more advanced than CATIA V5 because you are able to get the complete contextual menu commands on the right click. So it is much faster here. You click any surface, immediately the relevant features are highlighted. The relevant operations that can be done further are also highlighted. So now with the help of this kind of checking tools, I can check and repair the surfaces, again keeping the boundary conditions on. So this way, it has CATIA generative shape design has evolved a lot on 3DEXPERIENCE CATIA. I mean, there are multiple advanced features which are coming. Here, you are able to reduce more than 30 to 35% of the design time because everything is available on the right click. So the contextual menu, which is there to help you in terms of picking the right features and commands, and you are able to reduce your total design time in this fashion. So not only that, you can also interact with other applications, be it simulations or manufacturing, or it could be even the social collaboration applications like PLM. Everything is inbuilt into single user interface. So that's the most important power of 3DEXPERIENCE CATIA here. So here, not only checking the surface, but also we are able to repair them as per our requirements without affecting the actual shape of the surface. So this is how we can work on. Some of those advanced features are available here, and I will not be looking much into the advanced features at this point of time, but I'll be looking into the important aspects which have come into 3DEXPERIENCE CATIA. So the other aspect which I was talking about was generative design for design optimization. So if you look at the traditional design, everything happens on the established practices and design experience and also the design iterations. But in this case, in the traditional approach, you never know what is the best optimized shape that can be obtained by reducing the weight. So here, when I look at the generative design, software will run through your optimal design as per the requirements given, and again keeping all the functions intact, it is able to come out with the most flexible and also the effective design, which is also highly reduced weight. So in this example, I wanted to highlight how software is able to find out the topology and shape optimization for a given component here. So this is an example of a door hinge. Basically, here we are not we are not checking whether this shape is meeting the requirement, but we are asking which shape is going to meet the requirements in the best possible way. So if you look at the traditional modeling approach, we have started with exact geometry in V4. As we moved on to V5 on Windows, we moved into exact design approach. Then we moved into knowledge-based engineering, including which uses like knowledge advisor or knowledge ware expert modules in order to bring in the alternative designs at the click of a mouse button. And then we moved on to the next level, which is called experiential engineering. So this is where the generative design comes in place. So this is again connected with automated and intelligent guided design, or we can simply call augmented design. I can say computer augmented design. And then this augmented design is capable of recognizing the right shapes of a given component without losing its functional aspects. So at the next level, we have neurosystems engineering, which is based on complete artificial intelligence. So on 3DEXPERIENCE CATIA, you can see AML infused generative designs coming on to 3DEXPERIENCE CATIA. So here I will take an example of a function-driven generative design approach. for design optimization here. So this is an example of a component. First, we start with the function specifications. So once we set the function specifications, we enter into trade-off studies with the help of manufacturing constraints. So typically it could be milling or casting or machining, or it could be 3D printing. So we look at all the alternative concept studies, and then we look at the final detailed design, which we are going to come up with, which will meet our functional requirements as well as the weight optimization and shape optimization. So I'll take this example of door hinge, which is taken from here. So in this example, we are talking about a door hinge. So right now it has its functional requirement, right? The kind of kinematics mechanism it has. Now I need to look into this particular shape, which is the current shape, and see what is the best way to optimize this design. So first I need to set the boundary conditions, clamping conditions, and also where the loads are acting. So now I am moving from design to simulation. And also I am setting the manufacturing constraints for this particular component, which is door hinge here. So once I set this, simulation setup is done, I am able to set even manufacturing constraints, say from the perspective of milling or casting, or it could be even machining or 3D printing. I'm able to set up those manufacturing constraints here along with the simulation setup and run through the iteration process. So when I look at this iteration process, now the software will find out where the stresses are coming in and where the material can be removed basically. So now based on the manufacturing definition, whether it is milling or casting or something else, based on that manufacturing definition, now software is able to calculate the optimized design shape. Now I need to look at optimized design shape from the manufacturing constraints perspective, and I'm able to fit in that the new optimized design which is seen here. So in this way, software is actually doing the generative function-driven generative design with the help of simulations as well as the optimization, which is running as a solver in the backend to provide this kind of the weight reduced as well as the best shape model which is available for our design. So this way, this is again a part of 3DEXPERIENCE CATIA. So we are able to reduce this complete weight. We are able to remove the material where it is not needed, and we are able to come out with the final surface geometry, which is fully functional at the same time, meeting all your requirements, which is more aesthetic also at the same time, which is also more cost effective. Now we move on to the model-based definition. You all know the GD&T, basically the functional and tolerancing annotation module in CATIA V5. So this is basically done in 3DEXPERIENCE CATIA in a better way, I would say, because you are able to create all the complete dimensions along with the tolerances and also the specifications on the 3D model itself very effectively. So I will take this example of this particular model, wherein the software itself is able to run through the semantic tolerancing model, and it is able to generate the semantics tolerances along with the dimensions here in a single click of a mouse button. Earlier we used to do it individually, but now we can, once you define all the parameters here, once you run through the semantic advisor tool, you are able to create the complete set of dimensions and tolerances along with the datum planes, and also whatever that is needed in terms of the model based definition. So here this is an example of a specific model here, which is a speed sector assembly. Now once I go through this detailed definition of this, I'm able to run through the semantic approach. So once I'm able to define this mechanical junctions and rest of the portions here, now I will go to tolerancing annotation advisor role basically on 3DEXPERIENCE CATIA. So we can directly generate all the tolerances at one hit using this particular tool. So in the past, we used to do it individually. Now here, the software tool itself will generate all the tolerances based on the definition which is provided in this fashion. So now we can adjust them, or we can eliminate some of those which are needed, and we can separate those things properly. So this is how this model-based definition is done in an automated fashion on a 3DEXPERIENCE CATIA. So there are so many advanced features which have come on this digital platform. It will also highlight how many number of definitions have been given in terms of dimensions and tolerances. So CATIA has evolved a lot in terms of the digital application here. Now compared to CATIA V5, yes, there are several enhancements which have come up, which will ensure your design time reduction as well as the complete high productivity with more innovation in place. Similarly, we also have a lot of tools meant for knowledge ware and automation of designs. So we have we can make use of the Visual Script, and we can also create we can make use of the parametric definition and also the external parameters as well as internal parameters. We can do all those things effectively in 3DEXPERIENCE CATIA. Now I move on to model-based systems engineering, which is basically a new domain which is coming up faster. Today there is no engineer who is purely mechanical, right? So everybody is a combination of either mechanical, electrical, electronics, or something else. So it's a combination of, say, electromechanical engineer or mechatronics engineer, or it could be something like hydraulics engineer in combination with mechanical, or pneumatics and any other control systems. So now 3DEXPERIENCE CATIA provides this model-based systems engineering approach to manage all these subsystems and systems with the help of RFLP approach. When I say RFLP approach, we define the requirement analysis. First we do. We find out what are the functional requirements. So starting with the requirement analysis, followed by the functional requirements, and then moving on to the logical circuit definition. Last, we go for physical modeling. So that is nothing but the RFLP approach: requirement analysis, functional definition, logical circuit definition, and physical modeling. So the same approach is able to bring out all the systems and subsystems together, whether it is mechanical, electrical, or electronics. Today, you take any vehicle today on the market, especially in the EV segment, you see like it's a combination of mechanical, electrical, and electronics, right? So now this is helping us. This systems engineering is helping us to define this multidisciplinary behavior with the help of this RFLP approach. So we can do the complete 2D logical circuit modeling, and then we can connect this. We can connect this particular platform with the different subsystems, and we can see the final dynamic behavior of the system in a single way, in a single user interface. So now I will just click on this. This is basically an example of a four-wheeler, with a battery pack. Now, in this case, we can look at the battery design performance with the help of systems engineering approach. So this is again very much part of 3DEXPERIENCE CATIA. So in this example, first we look at the RFLP approach. So we need to look at the battery requirements, the logical definition, again at the functional requirements at the vehicle level, and we need to look at how many battery cells are needed to create a battery pack, again whether it is in a parallel mode or series mode. So we will open that and see, based on the total chassis module length, we are able to define the battery pack. So in this example, now I'm going to have a 2D logical circuit definition with respect to battery pack, and I'm going to define the battery pack based on the total module width which is available. Again, the number of cells also have to be defined, and whether it is parallel cells or serial cells, we need to clearly define that. And we need to look at the other two parameters which are important. Say like we have something like range anxiety, and also what you call the charging time, right? So we can define those parameters we can look at the design performance. We can run through the design of experiments and find out what is the best charging time for a given battery pack with so many cells and parallel and series cells, and at the same time, what is the range it can provide. We can do that complete virtual simulation in 3DEXPERIENCE CATIA using systems engineering approach. So in this example, we are looking at the battery pack again with how many number of cells. So we can accommodate more cells if the module is lengthy, and I mean if you have this more space enough, we can actually create more parallel cells or series cells, and we can update the entire model at the click of a mouse button. So once we see this kind of optimization done in CATIA, now I move on to the 2D logical circuit definition. Now in the backend we have something called Dymola, which is basically the Modelica language, wherein we are able to build the complete 2D circuit, and we are able to test and validate this 2D logical circuit definition using this. So we do this complete functional logical design in CATIA itself, and we are able to represent. Now here we have two important parameters. One is battery range, another is battery charging time. Now we can also bring in different norms and regulations coming from say Europe or North America. We can embed, which are already embedded into this platform. So we can make use of those standards, and we can build this battery operated electric vehicle. Now this is the circuit which we are developing with the help of CATIA systems systems engineer role, and we are able to define this in logical circuit definitions. So once I have the complete blocks of this 2D logical circuit, I will associate this 2D logical circuit definition with the 3D model, which is the physical modeling. So once I connect this with the physical model, now I'm able to run through this design of experiments, find out what is the best charging time that can be possible with this number of cells, and what is the range of the vehicle that you can arrive at. So we can run through the design of experiments in this fashion. So once I run through this design of experiments in systems engineering, so DOE, this is something, this is the calculator which is needed in the backend. So this is acting as an algorithm and solver in the backend to run through this design of experiments and find out what is the best possible charging time for a given number of cells, say 64 parallel cells and 80 serial cells. Now with that kind of number of cells, what is the charging time that is needed? What is the range that can be expected? So we can run through this variables and constants and find out the results from the software, and we are able to find out what is the best criteria for this battery design performance. So finally, we have come out with the three important elements. We were able to run through the analytics of design of experiments and find out what is the best possible design performance that can be obtained. So in this case, we are able to see the graphs, and we are able to find out the optimized battery design performance for a given number of battery cells. So this is all done in 3DEXPERIENCE CATIA with the help of model-based systems engineering approach. So here we have the combination of electrical circuits, physical model, that is mechanical 3D model. We combine these two aspects, and we see the dynamic behavior with the help of certain parameters. So this is something which is again available on 3DEXPERIENCE CATIA as a part of system. Then I move on to the digital experience platform with the unified environment approach. As I was talking about, combining multiple aspects of the organization. Say in design department, we have simulation department, manufacturing, quality, project management, and there are many more after field sales service as well. So we need to bring in all the departments together and ensure that all the softwares are working in a synchronized way under one single umbrella. So if you look at the traditional way, the file-based systems are all about managing the CAD data on folders, right? There is tons of duplicated data, and if you look at the relationships of which is not managed outside CAD, basically CAD world, which is again a kind of haphazard way. At the same time, it is difficult to manage the access rights. And also, if you look at the change management, again, it is very tough to manage all the old and new files. And the revision management, lifecycle, these are all not well defined. Although it is flexible to, create something in the folders, it can be deleted anytime. It can be cut, copy, pasted anytime. So the data can be easily destroyed without security. So this is where the database-based approach comes in. So when you have the database-based approach using the product data management, which is inbuilt into 3DEXPERIENCE CATIA as a part of regular basic roles, you are able to have the controlled access. At the same time, you are able to share them in a secured fashion. So here the IP protection happens first. At the same time, you are able to manage your revision controls and changes effectively and also you can minimize the duplicate data and ensure that you have the latest information and data available as a single source of truth. So this is something which is very much possible under digital experience platform, that is 3DEXPERIENCE CATIA. So I will take an example of end-to-end here. This is with respect to motorcycle. So in this case, now we are talking about a motorcycle. Here, if you look at this, the Enovia is the first part here. We are looking at Enovia as a web interface. We are able to run through our requirements, and also we have a dashboard which highlights about the battery capacity here. So in this case, I want to change this battery with 18 kilowatt hour battery with the existing one I want to replace with the new one based on the information that I received. So now we can look at the Gantt charts, timelines of this particular assembly, and then we need to look at what are the possible battery packs available in the system. Is it available in the catalogs and libraries? We can search through them. So now everything is happening on Internet Explorer or say Google Chrome or Mozilla Firefox. Now in this case, I have not yet touched upon the CAD world. I am still on the web interface. I'm able to open my entire bike on a web interface. I'm able to see, okay, where are the issues? Now there is an issue management which is happening. Now if with the current battery, in this case, battery pack, there are certain problems which are coming up, which I'm able to run through virtual simulations here. So when I run through simulations, I will be able to find out what kind of problems are coming in and how to replace this battery pack with a new one. So we go for the change management. So here we have a typical approach of lifecycle workflow and process, in work and progress, and then getting into release status, and then later on frozen status. So we have a simple lifecycle and approval process to highlight this. Now this is the battery pack housing. In this, I'm replacing my current battery pack with the new battery pack, so which is of 18 kilowatt hour. So now once I replace this battery pack, now the problem is solved, but I need to, the software in itself will run through this new definition of the EBOM. It will update the engineering bill of materials and highlight the changes here. So the change management is also very importantly captured here along with the modifications. Now you can see the in-work progress to the next state. Once it is released, the new engineering bill of materials with the new battery pack is now updated and available for all the users across the organization. So this can be again accessible from any location on iPad, tablet, or it would be even workstation or desktop or laptop, no matter. As long as you have a web interface, you can definitely open that and see how the changes have come in. So author will be definitely the CATIA user, but all the other people who are not in the CAD environment, they can also visualize the entire 3D data on a web interface. They can see, they can approve the processes. They can be part of this entire design process. They can also comment on that. They can also ask for the modification of or changes in this way. So when I look at this entire project, this is all happening on 3DEXPERIENCE platform, wherein I'm able to combine multiple aspects of, say, data management, version control, revision control, version management, and also I'm able to log in through a secured way. At the same time, I'm able to make the change management also seen, visible to all. So once the change management also will have to go through a process in terms of change request, change order, and then the actual change which is happening through the CAD engineer, and then finally the changes are automatically updated on the EBOM. So this is all happening on a single user interface. So this is the unified environment. Here you can run through the simulations, you can run through the the change management, BOM management, or any revision controls. If you want to go through this in a systematic way, this is the way to explore. So now, as a part of this CATIA 3D Experience CATIA, with the basic roles which are defined, we are able to actually get all these things embedded into our platform. Now, with the help of the basic roles like mechanical engineer or mechanical and shape designer role, or multidiscipline mechanical designer role, you are able to access this revision control, change management, and also the IP protection. You are able to manage all these things by default way. That is the power of 3D Experience CATIA, right? So I also move on to the what you call the artificial intelligence and also visual script based innovative designs which can come up from CATIA. This is again well explored under 3D Experience CATIA today, well utilized for smart cities programs and also for luxury car segments, as well as even for many other applications. So I will take you through one example on AI based generative designer, visual script designer in this way. So this is again coming on 3D Experience CATIA as the latest advanced features. So if you look at the patterns, we are able to generate the parametric designs in this fashion. So this way, like visual scripting designer will help you to quickly come out with different types of patterns which can be generated quickly, and at the same time which can be visualized quickly. So we are using this today for smart cities programs in that is in architecture, engineering, and construction. Of course, even for kind of stadium design that you have seen here. So we are able to come out with quick designs with the help of visual scripting designer roles, which are more intuitive and also which are infused with artificial intelligence. So 3DEXPERIENCE CATIA has really evolved over a period of time, and now today it is well impacting the entire world on especially on the product design excellence. So to look into the benefits, like if you move from CATIA V5 to 3DEXPERIENCE, yes, definitely you can see the productivity improvements, and of course the control data, which is basically the secure data and IP protection, and also you can come out with innovative designs which are highly intuitive and also highly aesthetic in nature. So this is what you can get. Today we are offering a specific migration initiative to move from CATIA V5 licenses to 3DEXPERIENCE CATIA. So you can definitely make avail of this program, and it is at a certain nominal cost. You are able to migrate these existing license of say MD2, SD2 or XM2 licenses. So if you look at the benefits of using 3DEXPERIENCE CATIA, yes, definitely you can improve upon 13% design time savings, and even your user interface is almost like 10 times faster than the previous CATIA V5, which was heavy in nature. And you can also have the immersive 3D experience quick modeling here, and then you can also have the real-time concurrent engineering and also the unified data model, which will run through design, simulation, and manufacturing. And also as a team, you can benefit from the digital twin models, which are created here as a digital assets. So when I say digital twin model, yes, exactly, we are creating the digital assets to improve the real world situation using digital assets. So here CATIA helps creating these digital twin models, and also we can do the kinematics at the multi levels, and we can create the business dashboarding. We can continue to socially collaborate with the applications which are embedded into CATIA, and by making use of basic rules of CATIA, you are able to connect with the entire organization, able to share the data and information which is latest again on any device at any time. So these are the important benefits in terms of operations, like it's a manufacturing ready design, and of course you can manage the large assemblies very effectively in 3DEXPERIENCE CATIA, and also it is process oriented, process centric in nature. You are able to have the design IP and full protection of your data. You can also leverage the existing assets for the competitive edge, moving from the traditional way to the generative or AML based designs, and also this can be scaled up for future as well. So it is easy to install, maintain, and scale and collaborate on cloud, which is available on cloud as well. Today we have many customers across India who are using 3DEXPERIENCE CATIA on cloud. We are able to deploy them within 1 hour, and they are able to start their project works immediately, and they are able to reap the benefits of this 3DEXPERIENCE CATIA online. So these are the simple benefits which I would like to highlight as a part of today's webinar. And to quickly summarize, like if you are moving from CATIA V5, we have a definitive scope of moving with the migration to 3DEXPERIENCE CATIA in this fashion. If you are having mechanical design to MD2 licenses, you can move from MD2 to M3K, that is mechanical engineer, with all additional functions and features at a very nominal cost. So not only mechanical design, you will also have the basic structural simulation, and it is also capable of providing the 3D preparation for 3D printing, and also do the digital markup along with the functional tolerance and annotations, that is model based definition, as a part of this M3K role. So this migration from MD2 to M3K is very much possible. In the similar fashion, we have migration from hybrid design 2, that is HD2, to MES, that is mechanical and shape engineer role. Again, you see the basic functionalities of assembly design, drafting, surfacing, all these things are there. Along with that, you also get a plus additional applications like say knowledge-aware modules. Under mechanical design, you have smart mechanical components, weight analysis, weld design, and also you have got advanced surfacing functions like freestyle shaper, generative shape developer, basically for unfolding the surfaces. Also healing module, basically meant for healing assistant, that is nothing but meant for repairing the surfaces coming from outside CATIA world. And then we can also have the IP control we have the both step and IGS formats also coming in, which is not part of HD2. So we can migrate from HD2 to MES to reap all these benefits in a very effective way at a specific nominal cost. We are also running the specific offers on this, and it is available on premise as well as on cloud. Similarly, if you want to move from hybrid design to mechanical shape engineering M3S, it also covers kinematics and most advanced surface functions like morphing and also freestyle, reverse engineering as well. Like you can also bring in point cloud data into the software, make the surfaces models generated out of it, and are able to recreate the entire model using the reverse engineering approach from precise shape preparation and also virtual to real shape morphing. So we have several applications which are coming as a part of this M3S. So probably you can go through this migration, packages which are readily available today. Today, most of our customers are moving in this direction. Like we have Ashok Leyland, Tata Motors, and Mahindra has recently tied with Dassault Systèmes to work on 3DEXPERIENCE, CATIA, and many other applications. And also we have Hyundai's, Audi's, BMW's. Everyone is on 3DEXPERIENCE platform. And yeah, you see all the latest projects on Airbus, Boeing, and also many other aerospace OEMs like Joby Aviation. They are all working on 3DEXPERIENCE platform on CATIA. So this will be helpful for you to switch from traditional CATIA V5, which is an electronic software, from CATIA V5 to CATIA 3DEXPERIENCE, which is a digital software. So this way, we are going to help you to migrate from existing licenses, because you have already purchased these CATIA V5 licenses. You have been using them. You can definitely be 200% effective using 3DEXPERIENCE CATIA roles. So if you have any specific information, you can contact us. Here are the numbers. You can connect with us. You can even send a mail to info@pdstechnologies.com.
Thank you, sir. I think that's all the questions we have. I would like to thank Shri Kumar sir for your delivery of the webinar. I'm sure audience would have been benefited by this. I would again request the audience, if they have any questions further beyond that, they can always reach out to us. Our queries, our contacts are given below, are displayed on the screen, in fact, and you can call us or you can mail us, and we'll definitely get back to you with the best possible solution. Before leaving, I would also request the audience to kindly fill the feedback form, which would help us in curating the content for the future webinars. Please do stay tuned for our future sessions and webinars. We do post regularly on social media. So thank you again for joining us. Thank you, Kumar sir. Thanks a lot.